Hello, Assalamu alaikum dear students. Today our topic is about the net present value of the project. So this is as we discuss the selection and rejection criteria of the project, and in that selection and rejection criteria we have a techniques by the name of net present value. So net present value is a techniques through which we can accept the project or we can reject the project. Before that, we will find out the net present value, and if in net present value become positive, so normally the selection and rejection criteria is that when NPV is greater than 0, so we will accept the project, and if NPV is less than 0 means negative, we will reject the project. Now, what does it mean by net present value? So, net present value NPV of the project is equals to the present value of expected future net cash flows discounted with cost of the project minus initial cost incurred. Net present value of the project is what? The when from the project the expected future cash inflows comes, and when we discount those future cash inflows of the project with a discount rate, and from that amount when we sum it, and the sum of all the discounting cash inflows when we subtract the cost of the project, so that discounting sum of discounting cash inflows are called minus initial investment of the project, that is called net present value. Net present value we can also define that is the difference between the discounting cash inflows and cash outflow. Discounting cash inflow. Discounting cash inflow means when we received the cash in future and we discount it with some percentage. So the sum of those value, that is called discounting cash inflows. So when we subtract the initial investment of the project, or that is called cash outflow, from the discounting cash inflow, so the difference is called net present value of the project. Discounting cash flow is denoted by summation sum Ri divided by 1 plus I raised to the power n. Yeah, if we divide by 1 plus I raised to the power n. This portion, this is called what? This is called discounting cash inflow. This one here, if you looked out in the here, this is called discounting cash inflow. C naught or I naught. Instead of that, we also use I 0. Yeah, I naught. This is called initial investment of the project or cash outflow. This is also called cash outflow of the project. So when we subtract this cash outflow from the discounting cash inflow, so the difference is called net present value. Clear now? Now, what are the advantages and disadvantages of the net present value of the project? The advantages are the net present value that it includes and consider the time value of money. Like time value of money concept says that dollar you have today is much more powerful than the dollar of tomorrow. So in the net present value we are considering the time value of money. In the payback period we were not considering the time value of money. So that was the disadvantage of the what? Of the payback period. But here in the net present value techniques, project manager considered the time value of money. So that is the advantages of the NPV. Second one advantage of the NPV, it measure the excess and shortfalls of the cash flows, positive result and negative results. It means that NPV calculate the excess as well as the shortfalls of the cash inflows. The excess means that when we calculate NPV and the difference between the discounting cash inflow and the initial investment of the project, that comes positive. So it means that our cash inflow is in excess than cash outflow. Clear? In third one, it measure all the cash flows. It means that all the cash inflows here we are calculating, and no one cash inflow is remain from the calculations. What are the disadvantages of the NPV? So the disadvantages of the NPV is what's that discount rate. We are unable to exactly calculate the discount rates. We just only make the supposition for the discount rate. So this is one disadvantages of the NPV. Now, formula of the NPV is equals to summation Ri divided by 1 plus I raised to the power n minus C naught. Ri is the expected returns or future cash inflows. 1 plus I that is discounting factor. I is discount rate and n is the number of the time period, years, month, whatever. And C naught is equals to that, this is called initial investment or initial cost of project. Now we are going, dear students, to solve a practical question on it. Look at, this is the 6-year project and the initial investment of the project is $1 million. Like, let's suppose today we are going to make investment of $1 million. So this is cash outflow. That's why this is in the negative form. After 1 year, we will receive 2,90,000 from this project. In the second year, we will receive $3,20,000. In the third year, we will receive $3,53,000. In the fourth year, we will receive $3,89,000. In the fifth year, we will receive $4,29,000. And in the sixth year, we will receive $7,79,230. This is the cash flow column. Now, if the discount rate is 25%, the discount rate is 25%. In 25%, our value is going to devalued. So we will now calculate the discounting cash inflow. These are, look at these 290, 320, 353. These are the future. In future we will receive. Now we will receive that after 1 year when we will receive 2,90,000. Clear? So what will be their net value? So on 25% discount rate, so we will first calculate the discounting factor. How we will calculate the discounting factor? So 1 divided by 1 plus I. So I is now 25% raised to the power n. N is number of year here in this question. So year is 1 in front of 1. Clear? Like, look at here now, 1 divided by 1 plus I. So 1 plus I is 25%. 25% is equals to 0.25 raised to the power 1. 1 plus I raised to the power n. So here n is this one, 1. Number of time period, year, 1. So that is equals to 0.08. 1 divided by 1 plus 0.25 raised to the power 1 is equals to 0.08. In the second year discounting factor, so 1 divided by 1 plus 25% raised to the power 2, that is equals to 0.64. Similarly, for the third year, 1 plus 0.25 raised to the power 3. N is now here 3. So when we divided 1 by 1 plus 25% raised to the power 3, that is equals to 0.511. Now, and for the fourth year discounting factor is 1 divided by 1 plus I. So I is 25%, 0.25 raised to the power 4, that is equals to 0.4096. For the fifth year, 1 divided by 1 plus 0.25 raised to the power 5, that is equals to 0.32768. For the sixth year, 1 divided by 1 plus 25% raised to the power 6, that is equals to 0.26. So we find out these discounts factors. Clear now? This column. Now in this column, present value, we will calculate the present value. So present value formula if you remember, so present value is equals to future value divided by 1 plus I raised to the power n. So I take only, look at the formula of the present value, that is what? Present value PV is equals to future value FV divided by 1 plus I raised to the power n. We can also write this formula like, look at future value FV multiplied by 1 divided by 1 plus I raised to the power n. I can write also this one, raised to the power n. Okay. So I find out 1 divided by 1 plus I for each year. Now I will multiply this with the future value, and future value is, these are the 1 by 1 we will multiply by their concerned discounting factors. Clear now? Okay. Now what I should do now? I will multiply this 2,90,000 by 0.08. So that is equals to 2,32,000. What does it mean? It means that after 1 year I will receive 2,90,000. So their present value is 2,32,000. या सरचपा मेरे कि एमरोज अगर मां 2,32,000 दारें अगर डिस्काउंट रेट 25% as, so after 1 year the value will be of this 2,32,000 will be 2,90,000. Similarly, now this is future value for the second year FV. So 3,20,000. This 3,20,000 multiplied by 0.64. So that is equals to 2,04,000. Means that after 2 years, if I received 3,20,000, so today their value is 2,04,800. Or if today I have 2,00,000 4,800, and the return rate or discount rate is 25%. So after 2 years, this 2 lakh 4,000 will be equals to 3 lakh and 20,000. Clear now? So one by one we will calculate the present value. These are the future value. So this future value I am now calculating the present value at the 25% discount rate. After third year we will received 3,53,000. So now what is their present value? The 3,53,000 present value. So 3,53,000 multiplied by this discounting factor which we calculate 0.511, that is equals to what? 1,80,383. After 4 years now, 3,89,000, this is my what? The 4th year cash inflow, future value. And when I multiplied this future value with 0.04096, so that will be equals to 1,55,720. In the 5th year same, 4,29,000 when we will received. So we multiplied this by their discounting factor 0.32768, and their present value, that is equals to 1,37,353. Means that after 5 years when we will receive 4,29,000, so today their 4,29,000 value, present value is 1,37,353. Or simply, if today present I have 1,37,350, and if I invest it on 25% returns discount rate, so after 5 years this 1,37,000 will be equals to 4,29,000. In the 6th year we will receive 7,79,230, and when we multiplied this with a discount rate or discounting factor 0.26, so that is equals to what? That is equals to 2,02,599. Now we calculate the present value, and this column is called what? That is the present value. What is this? This is what? This is RI. This 2,32,000 is RI divided by 1 plus I raised to the power n, discounting cash inflow. This is also called present value or discounting cash inflow. So one for each and every year we calculate the present value or discounting cash inflow. This is the discounting cash inflow of the 4th year, this is the discounting cash inflow of the 5th year, and this is the discounting cash inflow of the 6th year. So, and these are also called what? These are also called present value. Clear now? So now if we looked out the formula, so formula says summation Ri divided by 1 plus I raised to the power n minus I naught. Where is I naught? I naught means initial investment of the project, yeah, cost of the project. So 1 million, that is I naught, yeah, C naught. C0, this 1 million is what? By C0. Now put the value in the formula. NPV is equals to summation, this symbol is summation symbol, Ri divided by 1 plus I raised to the power n minus C naught. So the sum of all these value, when we sum this column, this present value column, 2,02,599 plus 1,37,353 plus 1,55,720 plus 1,80,383 plus 2,04,800 and plus 2,332,000. this discount rate not by minus 1 million ये वाली मीनिंग है add ना mechanism सिर्फ ये discounting a present value when we add it so their addition that is equals to 11 lakh 12,503.4 dollar their sum this RI summation 1 plus I raised to the power n minus C naught C0 C0 is initial investment or cost of the project that is 1 million. So now 11 lakh 12,503.4 minus 1 million that is equals to 1 lakh 12,503.4. So NPV is positive. When NPV is positive, so acceptance and rejection criteria is what? When NPV is positive. Positive means greater than 0. So we will accept the project or investment project and vice versa. So in this case we will receive the project. Why? Accept the project. Why? The reason is that one, that when we calculate the NPV on 25% discount rate, so our NPV becomes positive. Answer of becomes positive. That's why we will accept the project. So hope you will got this concept, dear students. Now this is a numerical 2. You will calculate the net present value for project A, project B and project C with discount rate 10%. So I is now 10%. Easily I hope so that you will do this project calculation. You will make the calculation of the net present value for that